Greetings everyone. I am Uday Sharma from the EEE Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic vibration for faulty detection in electrical machines. Machines have become a part of our life. Rotary machines are mainly prominent among them. As nothing comes without imperfections, machines also comes with few imperfections or to say faults. As we are speaking about the rotary machines, most of them work with the bearings or ball bearings. These ball bearings can have faults like breakage of the ball bearings due to wear and tear of the machine, cracks and openings or gaps in the ball bearings. It is good to detect faults in any machine before causing any damage. One such method to detect the faults in a machine is fault detection by vibration of a machine. This can be also said as vibration for fault detection in electrical machines. As we know, each machine containing a moving part produces or gives a constant vibration or resonates a certain frequency. These can lead to each machine producing a particular or significant vibration signature. Therefore, a change or varying in the signature tells us that there is a fault or any damage in the machine. This can be used to detect any faults occurring in the machine. The aim of the process is to detect the faults in the early stage so that the damage can be reduced. The machine here in this process is continuously monitored throughout its working. Vibration for fault detection in electrical machines. Firstly, the raw or original signal is measured or taken. These signals are measured using an accelerometer. As we can see, each machine has certain levels of thrust and curves and certain waveforms. And these vary apart from the conditions. Here, the experimental setup of the experiment can be seen. Here we have the so many paths considered of a few. Let us consider a rotary machine, and it has so many paths like the outer race, cage, roller or the ball point, ball bearings, and the inner race. Let us discuss about this later. For example, this ball bearing rotates and makes certain rotations, and this inner race also rotates as the along with the bearings. This ball bearing rotation and the inner race rotation resonate with each other and produce a certain frequency. But let us consider a ball or crack in this race, outer race or inner race, on the crack ball bearing. When this bearing comes near to the accelerometer, they produce a certain disorder or crack impact in the waveform. As we can see, this waveform is distinct apart from other two waveforms. As this can be said as a simple experimental setup for the vibration for fault detection in an electrical machine. Bearing vibrations are present in all types of rotating systems and motors. Anti-friction bearings are an important part of the motor. The bearing usage influences the whole rotating system. Bearings have the following defect source: inner race, outer race, roller spin, and bearing cage. All these introduce identifiable defect frequencies. Because there is no allowed amplitude for these frequencies, it should be follow the presence of detect frequencies harmonics. This is a signal after pre-processing. As we can see, this the machine analyzes in three axes: the frequency on x-axis, y-axis, and z-axis of amplitude to time. This is continuously monitored, as said in the previous slide. Here we can see the amplitude of a normal machine and how the waveform and the graph is. Here, when a distorted gear or faulty gear appears near the meter, we can see the distinct changes among the graphs, the amplitudes, the crests and troughs, the waveforms, the frequencies, acceleration, everything changes when a faulty gear appears. Let us summarize this once again. Here, we can see the machine fault simulator, speed controller, and a top controller. The machine detects signals as input signals and the accelerometer signals and default signals, etc. Time domain signals, vibration, and current are detected. These total data sets, vibration and current, are further divided into training data and testing data. They are furtherly analyzed. They are furtherly analyzed. The training data is used to build an artificial neural network. On this artificial neural network, finally compiles and detects and along with the testing data and checks whether they are coagulating with each other or mutually cohabitated with each other or not. And this gives its final decision whether the system has any faults in it or there is a clean system without any faults. Thank you. This is Uday Sharma signing off.